Hi guys, today's class I would like to discuss dimensions of physical quantities. So this concept is entirely new concept for us. But this concept gives an important information how we deal with physical quantities. So let's learn about deeply what are these dimensions regarding physical quantities. Suppose any physical quantity in nature, physical quantities described by its dimensions. First of all, what is a physical quantity? So physical quantity is nothing but which can able to measure. So let's take density. So density is a physical quantity. Density rho equal to mass upon volume. Now the density we need to represent in terms of very basic physical quantities. We are having seven basic physical quantities. So among the seven basic physical quantities, we learned that very basic units: length, mass, time, temperature. It's time. Second goes to temperature, and intensity and mole, amount of substance and mole, and last one goes to length, mass, time, temperature, intensity, and mole. So last one goes to ampere. So these are the seven basic physical quantities. Suppose if you are able to represent any physical quantity in terms of these all seven basic physical quantities, that seven basic physical quantities is depends on the derived physical quantities. So in this case, if I take an example, the mass, if we can take the letter capital M itself only, and volume we can take in terms of length times width, also we can measure in terms of length, and height also we can measure in terms of length. So altogether, if we can write this expression, is equal to m upon L cube. L times L times L, which gives L cube. And if we can rewrite this as m L inverse cube, or m power 1, if you can take that m power 1, and if you can put it that in a square bracket, so we must put it that in square brackets. Now we can say these are the dimensions. See, these are the dimensions for density. So we represented that density in terms of mass and length, very basic physical quantities. In mechanics, we used to represent any kind of physical quantity. In mechanics, we used to represent any kind of physical quantity in terms of these three basic physical quantity: mass, length, and time. Now these are the dimensions for any physical quantity. Let me take an example. So here one more example I would like to take. It's force. I would like to write the dimensions for force. First we need to know the formula. Force equal to mass times acceleration. The force units are kg is mass unit, and acceleration meter per second square. Now the kg we can represent in terms of capital M, that is the basic unit, And meter we represent in terms of length, that is also basic unit, and time we can represent in terms of t, in terms of basic unit. So if we can rewrite mass ml t inverse 2, now this became mlt inverse 2 is the dimensions of force. So likely any derived quantity other than the basic quantity, any derived quantity, if we represent, so if we represent in terms of mass, length, time, so that becomes the dimensions, so the dimensions of the physical quantities. So these dimensions we can represent in terms of dimensional equations. Dimensional equations are nothing but the way we represent this together. So this is only we can call as dimensional equations. Suppose write the dimensional equation for volume. So what the volume formula we can write? So length into breadth into height, and everything we can measure in terms of meters. So length also in terms of meters L, and breadth also in terms of L, and height also in terms of L. So we can get L cube. But whenever we can write that dimensional equation, we must include the rest of the two terms. It means the mass and time also. So here mass and time, they do not come in the volume, but we can write that in terms of m power 0 and t power 0. Now this became the volume dimensions m power 0 and L cube and T power 0, and this we call it as dimensional equation for the volume. So if we can write that volume V equal to m power 0 and L cube and T power 0, and especially this we call as dimensional formula. This we can call as dimensional formula. So on the course of time we need to learn certain dimensional formulas. So if you can check the NCERT textbook last pages. So certain appendix A9. So there are the physical quantities, so many, almost 70 to 80 physical quantities they represented. So all physical quantities written in terms of dimensional formulas. So these all dimensional formulas, so we will learn in the course of time. So no need to remember all these things right now, but when we can deal with the one each chapter, so in that one each chapter we will encounter with the corresponding formulas. When we are dealing with the corresponding formulas, so we automatically dealt with this dimensional formulas at that time itself only. But to get the preliminary knowledge, so just you can go through all these dimensional quantities from the textbook appendix A9. So the all physical quantities, length, mass, time, momentum and accelerations, and everything we were representing in terms of a dimensional formula. So that dimensional formula contains a square bracket in terms of the basic physical quantities. So let's learn about some of the examples regarding the dimensional formula. Let's derive one more dimensional formula for a physical quantity. For this, let me take an example for pressure. If you can write the pressure, so what we can write the pressure formula? Pressure P equal to force upon area. Force upon area. What is the force dimensions? From the early expressions we derived the force dimensions. Force dimensions are M, L, T inverse 2. So it is M, L, T inverse 2 upon area. Area we can write L into L times L, it becomes L square. So because area we can write in terms of length into breadth. So M L T inverse 2 upon L square. If you can rewrite the expressions, M L T inverse 2, if you can take that denominator to the numerator, the L square becomes L power minus 2. So the final expression, if we can get that M L power minus 1 and T power minus 2, so these are the dimensions for pressure. So likely we will derive for a given physical quantities the dimension formula. It means the physical quantities we need to convert it in terms of the basic quantities. So let's learn much more about how this dimensional analysis will help us for the further calculations.